Hello, my dear students. Welcome to yet another session on YouTube Live, my dear students. So, here we all will be moving ahead with YouTube session. That is, today's discussion would be on rotational motion, my dear students. Rotational motion happens to be one of the hot favorite picks in Karnataka CET, and those who all are preparing for rotational motion in KCET segment. Okay, so I suggest you all please be a part of this particular concept problem based discussions on YouTube. Okay, so I hope you all are doing great here. So come on students, please join the session as quickly as possible. So that we can go ahead with all the sessions in a proper manner. Okay, so with this note, let me just begin our discussion for the day, dear students. So this is YouTube live session on Unacademy platform, my dear students. I heartily welcome once again each and every student to this particular session for YouTube live. So today's topic of discussion is rotational motion, my dear students. So rotational motion, as I was mentioning to you, this happens to be one of the most important concepts with reference to Karnataka CET 2021, and I will be solving some important problems on rotational motion at the early stage. Okay, so let us go ahead and begin our discussion, my dear students, quickly. In fact, this is my brief profile for your observation. I have taught JEE Advanced, JEE Main Physics for 19 years at Delhi, Kota, Bangalore, and almost all across India. I've taught closely to 10,000 plus students till date, and currently I'm working at Prarthana PU College in Karnataka, and this is my third month in progress on Unacademy. And in Karnataka CET platform, my dear students, I am ranked at number 2 right now. I'm the number 2 faculty with reference to Karnataka CET. Okay. Now, let us talk about what Unacademy can provide us. Okay. So, this is actually Unacademy plans for plus subscription. Okay, now Unacademy provides you various interesting interesting things related to Karnataka CET 2021 under plus subscription, and when you go with plus subscription, my dear students, you would be given a lot many things in addition to the special classes. Okay, and YouTube live sessions, all these are part of plus subscription, and with plus subscription you can get so many benefits. Now let us go ahead and take a look at each of them. So Unacademy plus subscription, we have for Karnataka CET 2021 aspirants. Okay, we have a 12-month plan in progress. Okay, and this 12-month plan, it is costing 12,375 rupees. Okay, and there is an EMI facility as well here. So the EMI facility is offered at 1031 rupee per month. Hmm? And we have a 6-month plan, my dear students, and this 6-month plan, it costs you 10,125 rupees, and with an EMI of 1,688 rupee per month, you can avail this. So EMI facilities are available on 12-month and 6-month plan. Now talking about the third category, that is 1-month plan here. Now 1-month plan, it is offered to you at 2,250 rupee, and this is only for new subscribers, not for existing subscribers. Okay, this is only for new subscribers. Okay, so this is what we have as pricing as such it is concerned. Now what we get, what you will be getting, you will be getting a comprehensive batch. Okay, live batch, and presently there are 2 batches which are ongoing, my dear students. Okay, and these live batches are meant for entire KCET 2021 preparation. Okay, and here what you will be offered out of this, so you can see that you will be given a premium content at affordable price. And we have structured live courses, dedicated live doubt clarification sessions are a part of this particular Unacademy Plus subscription plan. Now, live doubt clarification session in the sense a student can very easily present the doubt to the teacher, and on that live desk itself, the teacher will solve those questions. This is live doubt clarification session, my dear students, and we conduct quizzes at regular intervals for self-analysis. Quizzes are important for us. Then we have batches for complete preparation. As I was mentioning to you, the batches are there for full preparation for Karnataka CET with 2 subjects, with 3 subjects or 4 subjects as per your choice. Okay, then we have for additional preparation, testing is most important, no? So hence we offer to you DPPs, that means daily practice papers. Then we provide you full length mocks, and each of them come with analysis. So what if you avail Plus subscription? Definitely these are the plus things. Being a teacher, my dear students, I would like to tell you that if you are given something at something of this structure at a gettable price, definitely you people can go ahead and take a look at that. Okay, and single subscription will give you unlimited access. So that is the most important thing for us, my dear students. And in order to avail a 10% discount here, okay, so you can avail 10% discount by using the code Uttam Live. Uttam Live is my code for your subscription, my dear students. You just go ahead and get a 10% discount straight away out of this. Okay, so this is regarding our Unacademy Plus subscription, my dear students. I hope you all will be benefited out of it, and I will see each one of you in the forthcoming KCET in the topper list. Okay, with best wishes to everyone. Now let us progress to our discussion for the day, my dear students. Now here is the question. A turntable is rotating in a horizontal plane about the vertical axis, passing through its center with an angular velocity of 20 radian per second. It carries upon it a flywheel, okay, rotating with an angular velocity 40 radian per second about a horizontal axle mounted in bearings. Okay, find the angular velocity of the wheel as seen by an observer in the room. Okay, now turntable is rotating in a horizontal plane. It is rotating like this. In a horizontal plane, it is rotating in this pattern. Okay, and about the vertical axis, so this is the vertical axis that we can consider. Okay, passing through its center with an angular velocity of 20 radian per second. So it carries a flywheel rotating with an angular velocity of 40 radian per second about a horizontal axle mounted in the bearing. So obviously here we have a flywheel which is mounted. Okay, and this flywheel is rotating with 40 radian per second. So now they are asking us to find angular velocity seen by the observer. So I being an observer, I will be observing in this direction or in this direction. So what will be the angular velocity in this direction? This is what they are asking, right? So now if you just consider the situation here, as you can notice, I will be considering this vector triangle here. Omega t, omega f and omega r is the resultant component of omega t and omega f here at an angle theta. Okay, so now we can say as the axis of turntable is vertical, its angular velocity omega t is directed vertical. So angular velocity omega t will be directed vertical. Okay, and the axis of flywheel is horizontal, therefore its angular velocity omega f also I must consider. So hence angular velocity of the flywheel is omega f. Okay, omega t is what? It is the angular velocity of the turntable. Now these two are mutually perpendicular to each other, and thus resultant angular velocity is omega r here, vector omega r. So accordingly I tend to see that I can write omega r is equal to vector sum of angular velocity of flywheel and angular velocity of the turntable. Okay, so thus I can write magnitude of resultant angular velocity as square root of omega f square plus omega t square, that is obviously given to us as 40 and 20. So 40 square plus 20 square I can write. So this will provide me root of 2000, which will be 400 into 5. So 20 root 5 radian per second. Now this is the magnitude, my dear students. Now let us find the direction, because in the option they have given us magnitude as well as direction, right? So hence omega r lies in a plane which makes an angle theta. Now this is making an angle theta here. So accordingly I can write this as theta is equal to tan inverse of omega t by omega f. Okay, so that should give me tan inverse of 1 by 2. Okay, so tan inverse of 1 by 2 is the direction and magnitude is 20 root 5 radian per second. So this is the answer, my dear students. Okay, I hope it is clear. Any doubts, my dear students? Any doubts you have in this? Fine. Now let me just progress to the next question. Question number 2. A mass of 2 kg is rotating on a circular path of radius 0.8 meter with angular velocity of 44 radian per second. If the radius of the path becomes 1 meter, what will be the value of angular velocity. Okay, so mass of 2 kg is rotating on a circular path of radius 0.8. Okay, now it is given like this. Okay, so radius is given as 0.8 here, 0.8 meter, with angular velocity of 44 radian per second. So omega is given to us as 44 radian per second, and radius of the path, if it becomes 0.1, what will be the value of angular velocity they are asking. Okay. Now over here I will take I1 and omega 1 as initial moment of inertia and initial angular velocity, okay, of the mass about the axis of rotation. Similarly, I2 and omega 2, I will take them as corresponding initial corresponding moment of inertia and angular velocity when the radius of the path is changed to 1 meter. Now, by conservation of angular momentum, I know that I1 omega 1 is equal to I2 omega 2, right? So hence I'll apply that, and here I can see that I1 given here according to given value, mass is 2, right? So 2 into 0.8 square, that will give me I1, so it should be 1.28 kg meter square. Similarly, now omega 1 is given to us as 44 radian per second, and I2 can be calculated here as what? 2 is mass into 1 square. That should give me I2 is equal to 2 kg meter square. Okay. Omega 2 is unknown. That is what we are supposed to find. So now, hence I can write 1.28 into 44 is equal to 2 into omega 2. So hence omega 2 becomes equal to what? 1.28 into 44 divided by 2. So here I can cancel this and write 22. So 22 into 1.28 should be 28.16 radian per second. Okay. So 28.16 radian per second is the required answer, my dear students. I hope it is clear. Okay. So let me just progress to the next question quickly. Now this is third question. A weightless horizontal rod is free to rotate about an axis OO'. Two masses each of 1 kg are placed at A and A' such that OA' is equal to O'A' equal to 0.2 meter. Now, a torque of 2 Newton meter is applied on the system which rotates about OO'. If the masses are displaced to B and B' such that O'B is equal to O'B' equal to 0.5 meter, then decrement in angular acceleration will be. Okay. Now we should find the decrement in the angular acceleration. Okay. So I'll be considering a situation like this. Now this is initial situation. This is final. Okay. When initially the radius is 0.2, for radius 0.5, we are considering these two situations. Okay. Now over here, in first case, I'll take moment of inertia of each mass. I'll calculate about OO' axis. Then I see that it is mass into distance from O'. It's a square I'll get, right? So mass is 1 kg into 0.2 meters. Okay, 0.2 meter is the distance, right? So 0.2 whole square, that should give me 0.04 kg meter square. Then moment of inertia of the whole system about OO', because rod is weightless. Okay, so hence I am considering for the whole system about OO'. Then I can write it as I is equal to 2 into, right, 0.04, because whole system has mass equal to what? 1 plus 1, 2 kg. So 2 into 0.04. For one mass, it is 0.04 kg meter square. So hence for the entire system, it will be what? 2 times of that. So that is why I am writing it as 2 into. So 0.08 kg meter square will be moment of inertia of the entire system. Next, I'll take I alpha as angular acceleration. Then torque tau can be written as what? Torque tau is equal to moment of inertia into angular acceleration. So thus alpha will become equal to torque divided by moment of inertia. Torque is 2 Newton meter and moment of inertia is 0.08 kg meter square. So clearly 2 ones are 2 0.04s I'll get. So thus I see that I'll get this as 25 radian per second square. Okay, so this is the value of alpha, angular acceleration. Now in second case, with reference to this, my dear students, okay, now here r is 0.5, right? So hence moment of inertia of the whole system can be written as what? 2 into 0.25, because 1 kg mass with 0.5 square will be what? 0.25 kg meter square, and for the entire system again it will be what? There are two masses, so hence 2 times of 0.25, that will be 0.5 kg meter square. Now therefore angular acceleration alpha will be equal to what? Tau divided by I. Now tau is 2 again Newton meter divided by moment of inertia is 0.5, so thus this becomes equal to 4 radian per second square. So now if we just refer back to our previous value, that is previous value is 25 minus 4, so that should give me the value as 21 radian per second square. This is delta alpha. Okay, so this is the decrease in the value of angular acceleration, my dear students. Okay, I hope it is clear. Let us go to fourth question quickly. Two spheres, each of mass m and radius r by 2, are connected with a massless rod of length 2r as shown in the figure. What will be the moment of inertia of the system about an axis passing through the center of one of the sphere and perpendicular to the rod? Okay, connected with a massless rod of length 2r. Okay, so now over here I'll consider the moment of inertia of the combined masses as 2 by 5 m into r square. 2 by 5 mr square is moment of inertia of sphere, right? So here r is equal to r by 2 here. So therefore I'll write 2 by 5 m into r by 2 whole square plus m into 2r whole square for rod plus 2 by 5 m into r by 2 whole square for second sphere. So thus if we just work this out, then we tend to see that we'll get the value as 21 divided by 5 m into r square. Okay, so this is the solution for question number 4, my dear students. Question number 5. Now, two circular discs A and B of equal masses and thickness but made of metals with densities dA and dB such that dA is greater than dB. If the moment of inertia about an axis passing through the center and normal to the circular faces is IA and IB. Okay, so moment of inertia about an axis passing through the center and normal to the circular faces. So this is the disk. Now we should find moment of inertia about an axis passing through the center and normal to the circular faces. So this is the circular face, no? So normal to it. So this is what they are asking. Now, firstly, I'll calculate IA and IB. Okay, IA is MA into RA square by 2 and IB is MB into RB square by 2. So thus I can write IA by IB is equal to RA square divided by RB square. Okay, so accordingly, as we know that MA is equal to MB, so when we take the ratio, now these two will cancel off. So thus I'll take this as first ratio or equation number 1. Now MA is equal to, I know that mass MA is equal to area into thickness into density. So pi into RA square is area into thickness into density of A. Similarly, MB is what? Pi into RB square into thickness into density, right? So hence, since it is given that MA is equal to MB for us, so I'll equate these two and I write pi RA square T into dA, pi RB square T into dB. Now here I can cancel off pi and cancel off T here. Okay, so then I'll be left with what? RA square into dA equal to RB square into dB. So accordingly, I can write RA square by RB square is equal to dB divided by dA. Now this is equation number 2. Okay. Now in equation 1 we have seen that IA by IB is equal to what? RA square by RB square. So hence I can very easily replace this part. I can replace this part by what? IA by IB. Okay. So hence from equations 1 and 2 I can say IA by IB is equal to dB by dA. And since it is given that dA is greater than dB, so from this I can comfortably say that IA is also greater, IA is less than IB, because from this I can very easily understand that moment of inertia is inversely proportional to density. So therefore I can say that IA by IB equal to dB by dA we have. So this proves that it is inverse proportionality. So therefore dA is greater than dB implies IA should be lesser than IB. So this is what we have as our answer, my dear students. Okay. So now with this note, my dear students, our session closes by now. Okay, so I will see you all back in my next session. Now in these problems which I have solved, okay, if you have any queries, if you have any comments, please go ahead and give us a comment. Okay, so thus I would like to thank everyone for being present in this particular live session, my dear students. So thank you one and all for being a lively audience on this YouTube live session, and you can see more of me in special classes as well. So you all can go ahead and attend my special class session as well. Okay, so in special classes I will be covering various topics, and presently you can see me in my special class at 4 p.m. today. Okay, so with this particular note, I would like to thank everyone for being present here, for being my good students. Okay, and I'll see you soon in the next session. Thank you very much, and my next session would be on 27th of this month. Okay, thank you very much. Have a wonderful time. Have a wonderful day ahead. Have a fabulous time. See you. Bye bye. Tata.